What's up, Bearcats? Alright, so it is FRQ4 2018. So this is one of those that you kind of knew was going to happen. You got a table. They're going to have you do a rhyme and sum somewhere in this problem. A lot of times they like to ask you for like mean value theorem or intermediate value theorem on these. And then right at the end, they give you some other equation that is either competing with this function or happening at the same time, and you have to compare them. And this problem does not disappoint. It is the height of a tree compared to the amount of time. So let's take a look at it, and we can go ahead and discuss it. So it says this is the height of a tree table, gives you the number of years, and then it gives you how tall this tree is going to be in meters. And then for part A, it says, hey, use this data to estimate h prime at 6. So remember, if this is the height of the tree, and we are talking about h prime, that this h prime is going to be the rate of change of height at t equals 6. So that's what the derivative represents. So if I looked here and I wanted to find the rate of change, well, I don't have year 6, and that's what these problems do. It's like, I need year 6. Year 6 is right between 5 and 7. I don't have the function. I can't find the derivative because I don't actually have a function to derivate. So what I'm going to do is, to the best of my abilities, I could find the average from 5 to 7 and say that's probably the best estimate for what it's going to be like at 6. So in their solution, you'll see what they did. They're going to take those 2 points. They're going to take these 2 points here, 5, 6, and 7, 11. Those are the 2 points. And they're going to pop it in the good old-fashioned slope equation that we learned in Algebra 1A. There it is, right? So it's y2 minus y1 over x2 minus x1. It gives you a slope of 5 halves. So you do get a point if you give me that. And then you have to have an interpretation with the units, which means that the rate of change of this height is 5 halves, and that's in meters per year. And you have to get that information from your table, meters per year, y over x. All right? Second question says, explain why there must be at least one time. Now hold up. I heard the magic word. It says, explain why there must be at least one. And when I hear the word at least one, I'm like, it's either MVT or IVT. It's either the intermediate value theorem or the mean value theorem. So it says at least one time. And then it talks about a rate. And when I see the rate, I'm like, yo, that's the mean value theorem. The intermediate value theorem is the easy one. That's just where there's a value. So I'm going to actually look for the mean value theorem here. It says, show me where there is, that there has to be at least one place where the slope is 2. Well, I'm just kind of looking at the numbers, and I am noticing that from 3 to 5, this goes up by 4. And from 3 to 5, this goes up by 2. So if I do the slope from 3 to 5, I'm going to get 4 over 2, which is 2, which means if the average slope from 3 to 5 is 2, then according to the mean value theorem, because this is a differentiable function, therefore it's continuous, there has to be some place where the instantaneous slope is 2. So let's see how they wrote it. So here it is. It says part B. There it is, from 5 to 3, that's the average slope of 2, so you get a point for that. Because h is differentiable, there it is, and it is continuous. So because it's differentiable, it is continuous. I got to state that. Therefore, the mean value theorem, I better use those words, will also have to have one place where h prime of c is worth 2. So if I stated all of that, I get the second point. You got to state it's differentiable and it's continuous. Okay? It's part of the problem. Whoa, hit the computer. All right. Let's go to part 3. Killing this thing right now. Use a trapezoidal sum. All right, so now we know, here's my rhyme and sum question. So use a trapezoidal sum with 4 sub-intervals. So why did they say 4 sub-intervals? Because when you look at your table, You got one subinterval there, two subintervals, three subintervals, four subintervals. So you have those are the four subintervals you have. Those are your little dx's right there. 1, 2, 2, and 3. Those are the widths of all the rectangles you're going to draw. You're going to draw four rectangles, right? These are rectangles. Indicated by the data, approximate the average height. Average height. Uh-oh. Uh-oh. Average height. 1 over b minus a times the integral from a to b of h of t dt. So that's going to be my average height equation. Sorry about that. But the good news is that this part of it right here, this chunk of it, I get to use a Riemann sum. And thank you very much for not choosing left and right, because we really wanted to try the trapezoidal, you know, because it's prep. We're just prepping, so might as well try that one. So here's their solution. Part C. There's my average height equation, just like we wrote it, from 2 to 10. And then I have to actually put it all out and get it. So that's this whole thing right here. It says trapezoidal sum, so I must be getting, if I ended up with the 60.75, that must be the sum. And then if I use the entire equation to get the approximation, that would be the approximation. I would make sure I include meters, because you never know if they dock you points for not having meters, right? All right, cool. Last part of the question, down to the end in record time. Here we go. Part D. Oh, goodness. The height of the tree in meters can also be modeled by the following equation. All right, so this is like another way to model the height of the tree. So this is not the table information. This is the formula information. So I'm going to have to deal with the formula as opposed to a table. X is the diameter of the base of the tree. Okay, so this is going to compare the base of the tree, right? X is the diameter. X is no longer, hold up. It's just like at school. We got people with blow dryers is good. Blowers outside my window. So here we go. So this compares the diameter of the tree to the height of the tree. And it says when the tree is 50 meters tall, right? So when g of x, right, when that height is, because remember, this is the height of the tree, is 50 meters, the diameter of the tree is increasing at a rate, The diameter of the tree, that's x, is increasing at a rate. So I am talking about dx dt is 0.03. Uh-oh. I'm going to have to do a rate problem, right? So there we go. According to what you think the rate of change of this tree would be. So if I have an equation like this, it says g is worth 100x over 1 plus x. I am going to have to find this with respect to t. So I'm going to have to take the derivative with respect to t of this entire equation, and I am going to get a bunch of information. And my question is going to be, what is the value for, what am I looking for? Let's check it again. What is the rate of the height of the tree with respect to time? So I need to find dg dt when g of x is 50. Is that right? So looks like that's what I'm going to have to find. So let's see what we get. We might need x, so we can do that real quick too. Like if this is my equation, then if g of x is 50, then I might want to do this real quick, 100x over 1 plus x. So I might want to solve this to make sure I can get this answer. And I can do it just like, well, let's do it the long way. So I get 50 times 1 plus x equals 100x. So 50 plus 50x equals 100x. 50 equals 50x. So this is all going to happen when x equals 1. So these are my two values I'm going to be able to plug in. X equals 1, x equals 50. So this is one thing I'll be able to plug in at the end. The other thing I'll be able to plug in at the end. And then, of course, you know I'm going to need this, right? I got to have that rate so I can find the only other rate that's left. So let's take a look at what their work looked like and make sure we format it pretty well. So they said if g of x is 50, then x equals 1. That was the work we just did. That's not worth anything. However, 2 points if you correctly realized I have to find d dt of this equation, right? So remember, you had g of x. So if you have g of x and you're trying to find it, then you have to find d dt of that. So you need the d. So d dt of this whole thing is going to be ugly. So I took the equation, I took the derivative of this whole equation right here, right? That's going to be the quotient rule, right? Remember, you have the quotient rule. So bottom squared, and then bottom times the derivative of top minus top times the derivative of bottom, right? Which gives me a total of 100 over 1 plus x squared. And remember, I did a d dx, so I have dx dt, right? This is all going to equal dg dt. That's what this is. That's what this says right here. So if that's true, then dg dt, that's this thing right here. Whoa, this dg dt will equal that ugliness, and then I plug in my points. I plug in a 1 for x, right? Because at x equals 1. I plug in the point 0.03 for the dx dt because that was that one, and I get 3/4. So if I got this answer here, that was worth that point. If I got the final answer, that was worth that point. Just say no chain rule. No 1 point, 1 out of 3 if no chain rule. It must be talking about doing this derivative like that, I guess. I don't know. I would have written g equals and got the answer doing it that way. So, all right. Well, hopefully you did well with that. 9 points, not too bad. Remember, this one was worth 2. So, there you go. Good luck. Catch you next time.